But with that, I will have to now quickly move on to the next session for the day. And just a reminder, we also have a raffle running. Like yesterday, if you've joined in, you know we gave away an Apple AirPods Pro. But we have on grabs today Apple smartwatches, another pair of Apple AirPods Pro, and the grand prize, an Apple iPhone 12 Pro. Yeah, so if you really want to get one of those, make sure you stick around for all the sessions, because you never know when I'm going to run the raffle. Another thing, I know it's lunch here in India at this point of time, so it might be a little bit slow and all that, but you know what? Looking at the panel, I see the chat. The talks are going to be very interesting today. So just head on quickly, grab a plate and get back to your desk and start watching the sessions again. So remember, we have a raffle coming up after this session, but right now, let's go now for the first technical session of the day. And here to speak about LINSTOR and its architecture and use cases with SODA is Yusuf Yilji, Solution Architect from Linbit, member of the SODA TOC. Over to you, Yusuf.
Hello, and thanks, Anvit.
Yes.
Thanks, everyone. That was a great, informative panel just happened. It was really great. And before I begin, I would like to thank all of my friends who worked day and night for this beautiful event. It's such an incredibly informative. So let me share my screen about. Okay. I think you can see it, right?
Yes, Yusuf. You can see your screen and your audio is also audible.
All right. After giving a brief information about myself, and I would like to move on to the presentation. For more than 10 years, I've worked in professional life in roles such as a storage admin, system admin, cloud operations manager, which was the biggest storage as a service company in Turkey. And for the last 1 year, I've stepped into the open source world and start working as a solution architect in Linbit, one of the valuable companies in the storage sector. And so from the very beginning of the SODA, we have been aware of the value, and we realized that SODA and LINSTOR will produce a great value together. And for this reason, we do our best to contribute to this valuable community. And while the SODA framework is getting better and better every day, and we are trying to integrate LINSTOR with the idea of 1 + 1 = 3, not 2. And LINSTOR plus SODA will generate more than the sum of its parts. And I now will brief you about Linbit, about our company a little bit, and LINSTOR and DRBD for a better understanding how this collaboration will make sense in the future. And if you have any questions, please do not hesitate to connect me at the email address I will indicate at the last slide. All right, so Linbit is an open source company based in Austria, Vienna since 2001. And we have some offices around the world. One of them is in Portland, Oregon, USA. We have like special partners all around the world. And our team is highly experienced in Linux, and they're maintaining and developing DRBD and LINSTOR, DRBD and LINSTOR. And we have some go-to-market products, but I'm just skipping those parts right now. And DRBD and LINSTOR, which I will explain a little bit later. And yeah, here. So let me explain what is DRBD and what is LINSTOR in really short, because we have short amount of time. And DRBD is basically a kernel driver, and along with some tools inside of it. And it allows you to replicate one block device from one server to another. In this case, there is 2 nodes here, but it's not a 2-node technology. You can go up to 32 nodes in one single resource, but this is a sample only. So in here, you have one node here, another node is here. The DRBD is sitting between the file system and the disk itself. And when some service, or let's say a VM or whatever it is tries to write something into the disk, and DRBD here is taking that write IO and sends it to the next DRBD device that is already paired, and it also writes in the second disk too. So this is the synchronous mode, and it writes synchronously on the local disk and the remote disk. And once both disks are written, DRBD goes back to the service and says, I write it. And if you're using asynchronous mode, which is also supported by DRBD, as you can imagine, it writes to the local disk and goes back to the service or file system, says, I write it. But it also sends the data to the second one, but it actually doesn't care if it's written or not. And this is this asynchronous mode, which will be the case for today that I will explain. And this is basically what DRBD is. It allows us to have some high availability in the local data, in the local systems, on-site systems, and it allows us to use disaster recovery scenarios in the long-distance replications. And DRBD is that simple. And let me jump into the LINSTOR. So let's say you want to create some DRBD pairs in your system. If you have 2 nodes, that's okay. You just need to modify a couple of config files. If you want an automation, you set up the pacemaker and so on, and that's it. But if you are using, let's say, a Kubernetes or OpenStack, VMware, OpenNebula, Proxmox, KVM, you name it. If you're using these kind of operators or platforms, let's put it that way, and you are constantly creating and deleting some replicated volumes in your system, you need something to automate this whole process. And you don't want to write one single command. You want everything to be automatic. And that's where LINSTOR comes into the picture. It is basically a software-defined storage that automates the Linux storage needs that is backed by DRBD replication. So let's say you need a 2-way replica VM in OpenNebula. And when you do that, there's a driver that is already connected to OpenNebula. OpenNebula creates that VM. And when it's done, the LINSTOR controller, which is stateless, sends a request to 2 of the satellites, which it finds appropriate, and creates that VM disk in 2 of these nodes here. So it basically creates 2-way replica VM disk into this cluster and connects it to the hypervisor automatically. Both LINSTOR controller and the LINSTOR satellite are stateless, and you can easily upgrade, downgrade, shut down, move, whatever you like. As you can see here, LINSTOR controller is only 1, but it can be high available in any system, also in Kubernetes. But the satellites needs to be installed in each and every node here. So this is basically what LINSTOR is, what DRBD is. DRBD is a replication technology that is all right. There is this is inside of the inside your system. So let me jump into where LINSTOR closes a gap in SODA. So SODA aims in a goal of building the unified framework for data and storage management, and unified distributed data storage and the application platform agnostic is the future, as we all know, and we talk about this whole sessions. And as a Limbit, we are planning to fit in the SODA in two ways. One is the disaster recovery scenarios, and the other one is the blazing fast software-defined storage for the block storage. And if I need, I don't think I need to explain what is disaster recovery, right? Because everyone knows it well. But it is basically a plan and processes for quickly creating an applications and the data after an outage. So this is basically it. So we are working on the integration of LINSTOR to SODA, as I mentioned. And LINSTOR is the fastest in the market, but it's not just fast, it has geared with a lot of features in it. And thanks to the DRBD that I just explained, in the core of the LINSTOR replication part, we can cover the disaster recovery scenarios in SODA clients. And DRBD can be worked as synchronous and asynchronous mode. And this gives us plenty of space on any scenarios, like high availability in local, like and disaster recovery in remote site in one single cluster. And also, LINSTOR has drivers and integrations, just like I mentioned, to Kubernetes, OpenShift, OpenNebula, VMware, we choose it. And as you know, on the disaster recovery scenarios, RPO and RTO is really important. And RPO is recovery point objective, and it can be like 2 or 3 seconds with LINSTOR. And RTO is depending on the application, but can be very low in suitable conditions. LINSTOR also has a snapshot shipping feature, as well as the asynchronous mode here. And with the snapshot shipping feature, so you can actually get over any kind of low bandwidth and high latency situations. And also you can use it for backup purposes. And failover and failbacks are seriously easy on LINSTOR. And thanks to the DRBD's management system, you can change the replication direction on both sides very easily. And on the last part of this slide is having a LINSTOR in this SODA platform. The benefits of having this is no vendor lock-in, fastest in the market on SDS, and supports most of the platforms natively. Integration in any hardware is possible, which lately we integrated into open composable APIs that you can open and down nodes within the LINSTOR itself. And creates resiliency against data loss and downtime via the data replication. And yeah, that's pretty much the benefits of having LINSTOR in SODA. So in summary, we know that open source is the future, and we know that 20 years, and we invested in this community along with these years. SODA Foundation is really valuable for us, and we are seeing unlimited possibilities here. What it become over?
Yusuf, I'm sorry to interrupt, but there are a few questions, and we are almost out of time.
Okay.
Yeah. So the first question is, does LINSTOR support on-prem to cloud replication?
Yes, it is supporting on-prem to cloud replication. You can do it.
And there's one more question. What are your thoughts on LINSTOR with SODA to tackle data management challenges, especially the disaster recovery use cases?
Actually, this is what I'm referring here in this slide.
Okay.
So with LINSTOR's disaster recovery capabilities, we are willing to solve this problem for SODA once and for all. And we are currently in the process of integrating it. So we are looking forward that SODA version that LINSTOR is integrated into. And we are actually currently working for that right now.
Amazing. I think some closing remarks, Yusuf, before we end. Oh, it's done. That's brilliant.
It's done. It's already done.
Thank you, Yusuf. I think this is also a very informative talk. And I think one of the use cases which we are actively working right now with Linbet. So we're looking forward to this collaboration being fruitful as well. Thank you.
We are also looking forward to that. Yeah.
Awesome.
Thank you, Anil.
Okay, with that, we will now quickly move on to the next session of the day. And this is going to be by Brian Drosmaita, Principal Software Engineer at Red Hat. And he's going to be speaking of the key features, architecture, and use cases for Cinder data management challenges. Brian is not attending with us right now, but we have a recording. So Ashit, if you could just play and maybe change the quality. I believe it is at a low quality at the moment. Okay, maybe a network issue there. It's all right. Maybe it could be a network issue. Over to you. Ashit, unable to hear them.
Yeah, just trying. Just wait a minute. I think there is some network issue. The sound is not there.
Oh, okay. Welcome to the new normal. Every virtual call or webinar has this issue. I believe we talk about data, but this is data, moving data right now. Lots of bandwidth being consumed everywhere. Just give us a minute there. We'll just try to sort this out. Having said that, remember, we have a raffle coming up post these sessions, so don't forget to keep signed in. Or if you're not signed in, please do sign in quickly.
Yeah, with just a minute, I'll set the audio somehow.
Ashit, you want me to try?
Yes, Anil, if you can try it out.
I'll just try once.
Yeah. Yeah.
Can you see my desktop?
Yes, yes.
Yes.
Yes,
Okay.
Nikhil, we can't hear. I know that. We're trying to get it sorted.
Is it audible?
No, there is no audio here.
1 second.
Hi, I'm Brian Rossmeda.
That was audible. That was audible.
Sanil, sorry, that was me. I just tried to play.
And how Cinder can help
Okay.
you address
Yeah,
it.
I think it's audible. Yes.
Quick agenda. We'll talk about OpenStack and Cinder, what Cinder does, how Cinder does it, what Cinder can do for you, which is what you really want to know about, and then how you can get involved in Cinder. The OpenStack, as you probably know, is an open source project for building a private or public infrastructure as a service cloud running on standard hardware. It also requires virtualization software and requires a base operating system. So you'll usually get OpenStack in some kind of distribution from Red Hat or Canonical that includes the virtualization and operating system components. Get more information about OpenStack, just go to openstack.org and you can find out everything you're going to want to know. Now, the OpenStack architecture is basically a number of projects that provide different cloud services via REST APIs. There's 6 basic services. So you've got the compute service called Nova that provides VMs. There's the networking service Neutron that handles all the networking in the cloud. There's an image service called Glance, the block storage service called Cinder, which I work on. There's the identity service Keystone and an object store called Swift. And there are a lot more services. So if you want to get a sense of how many things there are and what the APIs look like, you can search your favorite search engine with OpenStack API reference. And each of the REST APIs has a published reference guide that shows you what the APIs can do and how to interact with them. So that'll give you a good idea of how OpenStack is structured and how it hangs together. Now, Cinder, as I said, is the OpenStack block storage service, and it implements services and libraries to provide on-demand self-service access to block storage resources. Another way to put this is it provides software-defined block storage via abstraction and automation on top of various traditional backend block storage devices. The architecture is basically what you'd expect. So this is a quick schematic of it. So you have a REST API that will be interacted with by a client. There's a message bus that mediates between all the various services provided by Cinder. So there's a scheduler, there's the volume managers, and then way at the bottom there are the backends where stuff is actually stored. Not showed here are a backup service. There are a couple of other things that Cinder provides, but this gives you the basic idea. A client will make a request for a volume to be created, saying what type they want. The scheduler decides what backend this should go to. It hands off a request to the volume manager, and then the volume manager uses a driver to interact with the storage to create the actual volume. Cinder project has a bunch of deliverables. So there's Cinder, which is what I just showed you the architecture diagram for, and then there's a bunch of other stuff. So there's a Python Cinder client, which provides Python language bindings for the block storage service API, and also provides a command line interface. There's OS Brick, which is a library that Cinder provides that actually does the volume attaches. So Nova uses it when it wants to attach a volume to a VM. Cinder will use it itself when it needs to actually attach a volume to perform some kind of service to the volume. There's also a Python Brick Cinder client extension, and what that does is it extends the Python Cinder client so that you can easily do attaches if you're not trying to attach your volume to a VM. Then there's cinderlib, which I'll talk about in a little bit because that's really relevant for today. There's the Cinder Tempest plugin, which houses custom integration tests specifically for Cinder. And then there's Cinder Spec, where all the design documents are stored. So if you want to see any of this stuff, you can go to opendev.org/OpenStack/ and then name, where the name is one of these deliverables that are on the list. Now you may wonder, why are we looking at the horse from behind? Well, the basic idea is that block storage has to actually be stored somewhere. So the storage backends are essential to Cinder, even though we don't really write backends. Cinder supports different backends through drivers. So the drivers mediate between the block storage API, which provides a consistent interface to users, and particular backends. Now, strictly speaking, the drivers mediate between the storage backends and Cinder services, and they provide a consistent interface for the Cinder software to use. There are over 79 drivers in the Cinder code repository. And the supported drivers have functioning third-party CI systems that run on every proposed patch to Cinder. And this provides additional information for people doing code reviews, because we know whether that patch has broken one of the vendors or one of their drivers. So it allows us to do early detection of changes to Cinder code that might impact a driver, and also early detection of changes to driver code that might cause a regression in Cinder behavior. So what tests are they actually running? Well, they run against an OpenStack environment that are connected to the vendor's backend. So there's the OpenStack integration test suite that's called Tempest. And then there are additional Cinder-focused API and scenario tests that are contained in the Cinder Tempest plugin. As you may know, OpenStack is very configurable, and the basic OpenStack continuous integration can only run on a limited number of configurations. And also, the OpenStack itself doesn't have access to all the vendor backends. So we rely on the vendors to do that kind of testing. So that's great. All right, so using Cinder. Cinder's fully integrated into OpenStack, so it's very easy to use with OpenStack, of course. Cinder can also be used in standalone mode if you want to use it independently of OpenStack. And kind of key thing is Cinder can also be used to provide persistent volumes for containers. So as you know, there's a container storage interface that specifies the interface to enable a storage vendor to develop a single plugin that will work across all container systems that support the standard. So what's nice about this is storage vendors don't have to touch core code of container orchestration systems. The code is just used, right, they just provide the plugin. And then you can use Cinder with the CSI in 3 different ways, and that's what I want to tell you about. All right, so there's the cinder-csi plugin. So if you're running Kubernetes on top of OpenStack, and your OpenStack deployment contains cinders, as about 98% of deployments do, the cinder-csi plugin can serve persistent volumes from whatever backends are configured for Cinder. So that's Kubernetes code. And so if you go to the Kubernetes space in github.com, you can see the cloud provider OpenStack plugin. There's another way to use the cinder-csi plugin. If you're not running Kubernetes on top of OpenStack, you can still use it and have Cinder manage your persistent volumes by running Cinder in standalone mode. So Cinder can be run independently of OpenStack. Now, the advantage is that it gives you a wide range of storage backends, namely whatever Cinder supports. And as I mentioned earlier, we've got over 79 different drivers. Disadvantage is it's very heavyweight because you're deploying that entire system that you saw in that architectural picture, and you don't really need all that stuff. So that brings us to cinderlib. It's a deliverable of the Cinder project. I mentioned it earlier in that list. What it is a Python library that allows Cinder storage drivers to be used outside of Cinder. So it removes the database, the message broker, block storage API, the scheduler, and volume manager. So a lot of that stuff you saw in the architecture diagram, it yanks. So opendev.org/openstack/cinderlib is where you can see more about that. But the key point about it is it provides an interface to cinderlib for Ember CSI. So Ember CSI meets the container storage interface and it interacts with cinderlib, and then cinderlib interacts with the drivers that have been built for Cinder. So this allows you to use the Cinder drivers outside of Cinder, and what you get is reuse of well-tested software for many diverse hardware backends. So if you're interested in that, embercso.io. All right, to get involved in the Cinder project, it's an open source project, so easy to get involved in. We work on a 6-month development cycle with releases in the May and November timeframes. So I just want to give you an idea because you want to interact with us at the beginning of a cycle when we're still doing planning if you want to try to influence development. 2 ways to do it. You can go to the forum or summit and influence us, or you can come to the project team gathering where we're actually doing design discussions. And if you're willing to work on the project, that's where you come and that's where you can do it. All right, sorry I'm talking so fast, but I'm just out of time. So we got project documentation. There's a Cinder YouTube channel where you can see our meetings, and then general information, including meeting times, where the code repositories are, and how to contact people are at tiny.cc/cinder.info. I'm sorry I'm not here to answer questions, but it's 3 a.m. my time, and I would be even more incoherent than I am now. Thank you so much for attending, and I hope you enjoy the rest of SODACON.
Oh, that was a brilliant speech by Brian Mayata. As he mentioned, it is actually quite late for him. If you do have any questions about this, though, you can always head on over to the website quoted by him, or you can also post your questions here. We'll get them answered by Brian to you. With that, let's now very quickly move on to the next session of the day, and that's going to be by Shoran Liu. Shoran is the technical lead of distributed file storage at Oppo Cloud, and he's going to be talking about ChubaoFS and its architecture and the potential integration of ChubaoFS and Soda along with its use cases. Over to you, Shoran.
Thank you. Let me share my desktop.
Sure.
Okay, can you see my desktop?
Yes, we can see your presentation.
Okay.
Your audio is clear. Good to go.
Okay. Hello, everyone. My name is Shoran. I'm the maintainer of ChubaoFS project. So today I'm going to give a quick introduction to ChubaoFS, which can be used as an on-premise backend distributed storage for Soda. Okay. So first of all, what is ChubaoFS? It is a distributed storage system providing both file system interface and S3 compatible interface. The key objective of developing ChubaoFS is to provide a storage service for containerized applications deployed in large-scale container platforms. It has several features listed here, or you can call it sub-objectives, which we managed to achieve. For example, there is usually one cluster for all the applications with multi-tenancy to do some isolations. And it aims to support a large number of clients simultaneously. And it scales out easily and efficiently. And we try to optimize resource utilization. Also, it is friendly to both large and small files, performance-wise and capacity-wise. Also, it has a converged interface, which means you can access the same data with file system interface and S3 interface, which gives the customer a lot of options. So in the last slide, we talked about the objectives, and here's a high-level architecture showing how we achieve that. I'm not going to going through the details of the design, but only to give a general idea of the design essentials. Okay. So first of all, we tried, as you can see from the right figure, we tried to eliminate bottlenecks in the whole system. For example, you can see meta node can be scaled out as well as data node. And also control plane and data plane are separated. So the performance is not limited by the potential bottleneck of the master module. And also we deployed some proxies in front of this resource management module to relieve the pressure from clients, since our objective is to support a very large amount of clients. Okay, and second of all, we try to improve our resource utilization by sharing physical storage resources. As you can see, a volume is just a collection of logical partitions. And this logical partitions does not consume too much storage resource when not used. So in this way, this design can withstand a traffic peak by pre-allocating logical partitions. Since logical partitions does not consume physical resource, so it is not a waste. And this is just a design essentials. And if you have any questions, please feel free to contact us offline, and you're more than welcome. And next one, ChubaoFS integrate with cloud native community very well. As Brian mentioned in the last session, CSI driver can be used to access ChubaoFS. We support CSI spec v.0.3 and v1.0. So in this way, I believe ChubaoFS can be accessed, can be integrated with SODA seamlessly through CSI driver. This is released this year and has been used in production. Okay, so that's it for today's talk. Thank you for your time.
Thank you so much, Shoran.
Yeah.
So if we have any questions, we will be getting them to you and we can get them answered. Thank you again.
Okay, thank you very much.
All right, very swiftly now, let's move on to the next topic of the day. And we have with us Uma Shankar Mukara, co-founder, COO of MayaData. And he's going to be speaking on the key features of OpenEBS and Litmus and how integration and potential integration with OpenEBS and Soda can solve use cases. Over to you, Uma.
All right. Thanks, Sonit. Hi, everyone. Great to be here. I'm Uma Mukara, co-founder, COO of MayaData. You guys can see my slide, right?
Yes.
Yes, so I'm also a maintainer and a co-creator of two very popular open source projects in the cloud native space. They're OpenEBS and Litmus. I'll be talking about or introducing both these projects on why they are so relevant to SODA Foundation, or in general, how they're relevant to data management or data resilience in the cloud native space. So a little bit about MayaData. MayaData, we operate in the data management area of cloud native ecosystem, and primarily developing a lot of technology and working with the communities associated with the Cloud Native Computing Foundation. We are, in terms of PR authors, we are the 5th largest company donating code to this foundation. So that tells us how committed we are to be in the open source for the cloud native technologies. So primarily, these are the two projects that we started, now continue to lead the sponsorship of the development of both the projects. And if enterprises are looking for support of any of these two technologies together, they're available through our commercial product called Kubera. So today, in the next 8 or 9 minutes, the main topic that I wanted to cover here is what are the cloud native technology trends and how they are relevant to data and sort of foundation, right? So I think I heard through this conference this morning, there was a lot of acceptance and common knowledge around NVMe is the path forward as far as data is concerned. It is not a more technology for future, it is for present. And you see that people are moving already onto it, and it takes time. Obviously, data has been there for so long, and the shift has already started, and it will happen. So that's one thing, right? The other one is edge. In this modern days of communication, edge is already a reality. And then the other biggest thing that we all know is containers, right? The entire IT system is moving towards containers. So how these three things are coming together? How do you take this latest technology for storage and develop the applications to run on edge using containers and consume also the data around it, right? So that's a big deal, right? So anybody can go and provision it, but to operate it at production level, at the scale of edge, it is a big deal. So the main challenge that we foresee is about the challenges of provisioning and keeping them provisioned. That is called agility. The other one is portability, right? So your app may be running on one small data center off the edge, but it may need to be moved to the other. So how do you make sure that your application actually moves along with the data, right? And while doing that, you're not logged in into a particular technology. That's the biggest problem that you can ever design by actually writing into some proprietary technology. Your data is stuck, and your basically architecture is stuck with whatever that underlying technology, proprietary technology is. So that's the trend. Moving NVMe based data onto the edge using containers is definitely a trend that is taken acceptance. The other one is, well, you are able to provision, you are able to actually keep it running, but will it always be made available? How resilient your application data or application itself, right? Highest availability of the data. So that's the resilience part of it. So this is another trend of people trying to make sure that my applications run properly all the time, irrespective of multiple upgrades that can happen without your knowledge on the fly while you speak, right? So that's the cloud native ecosystem. Everything is left shift, and you're dependent on so many things, and things can keep changing. But still, that cannot be the reason for your non-availability of your service, right? So running a big data center or edge type of network continuously is a challenge. So many of you may have seen this on the left side, the keynote ending keynote of the recent KubeCon. CNCF has actually announced or shared the 5 technology areas that you can look at, and that is something similar what I'm also telling here, repeating chaos engineering and Kubernetes for edge. In Kubernetes for edge, primarily we see data is a major challenge, and running the data in a proper way, right? There's a question maybe I can take, is OpenEBS integrated with SODA? Yes, we make use of CSI drivers. That's the technology that is recommended to connect to the data. So OpenEBS provides the integration of CSI drivers, many of the CSI drivers, into one common API, so that as long as you have a CSI driver, you connect and make use of OpenEBS. So in essence, these 2 trends of this 5 is really are served by our projects, OpenEBS and Litmus. OpenEBS is the #1 container attached storage open source project that's in the CNCF, and Litmus is the #1 cloud native chaos engineering project in the CNCF ecosystem. So together you can take care of the 2 top technology trends: data, keeping the data, and keeping the data resilient and applications resilient around that. So a little bit about OpenEBS. So I mean, the question was about, will it connect? Yes, we used to solve the problem of connecting to your underlying data wherever it is stored, but over a period of time that was expected to be solved by a more common technology. So the CSI came in, and it's all solving that problem, right? But CSI is just solving the problem of connecting to heterogeneous system. It does not solve the other problems associated with the inherent data, right? So what about your data orchestration itself, and moving your data across this different clusters, and the data governance and data lifecycle? So there's a lot of issues that will come in when especially big technology stacks that get used in SODA or CNCF that come into the picture. So what OpenEBS does is OpenEBS provides you the native Kubernetes native technology that can work underlying with the CSI driver, and then it can connect to various different actual storage disks that can come in, right? So that's probably the biggest value add that we are giving, native Kubernetes based storage, and that unifies a lot of this value proposition. So these are the challenges. Just because you have CSI driver doesn't mean that you got everything, right? So it's only about connectivity, and what you really need is you are moving yourself to containers, and is your data also doing the same thing, right? All the benefits of your application being in a container, can we retain them when your data is also attached, right? So for that, the best way is wrap up the technology that manages your data also into a container, and then get the best of it, right? So that's what is container attached storage, and that is the fundamental architecture principle of OpenEBS. And with that architecture, you're basically keeping your data always available, and always extendable, flexible, and it is a microservice. It runs always in open source, and especially with OpenEBS, there's no locking, as it is completely open, all that stuff. So the other one is NVMe, as we all see. So OpenEBS has this newest storage engine called MayaStore that basically removes the bottleneck of the kernel while processing the data. So using OpenEBS MayaStore, you get the wire speed, and there's a lot of technology that's been put in. Primarily, it uses the SPDK, the Intel Storage Performance Development Kit, and it integrates very nicely into Kubernetes scheduling and control plane, and it works with this following way by bypassing the kernel, all that stuff. So do take a look at it. And quickly,
Uma, I'd like to interrupt. We have a time check. We have some questions. We have actually a question from Suman. Does OpenEBS provide any policy management solution for application data out of the box? And maybe after the question, you can have some closing remarks, because we are really out of time.
Sure. I think, I covered OpenEBS pretty well, so that's good. So the policy management, yes, first of all the configuration that goes with OpenEBS is declarative. So you can nicely fit any of this data deployment policies and data management policies with any of the policy management frameworks that's available. For example, it integrates very well into OPA. So fundamentally, it is a data stack itself, and then the data management is done in association with the Kubernetes resource management. Yeah. So with that, I would like to congratulate everyone for running this successful conference, and do take a look at both of our projects, OpenEBS and Litmus. They're on Kubernetes Slack, both the communities at OpenEBS and Litmus channels. These are our Twitter handles, and there are a great deal of docs available for both these projects. So I welcome you to look at both of them. Thank you.
Thank you very much, Uma, for introducing us to Litmus and OpenEBS, and we look forward to take the collaboration with you further. And I would like to thank all the presenters today, Yusuf, Brian, Shuran, and Uma, for spending their valuable time with us here at SODACON 2020.